Welcome to our next idea that we want to just cover in the world of matrix determinants. We've been covering up some topics and some concepts to understand the determinant better, and then the next thing we want to talk about is what we call cofactor of a matrix. Okay, so the ith cofactor of a matrix. How do I define that? So suppose A is an n by n matrix, that's a square matrix. Then the ij cofactor denoted by cof or cofactor aij is defined by the, so you have the cofactor ij is defined by -1 to the power sum of I and j, then the minor of aij, and then I've talked about the minors before in our previous lesson. So the minor is just I'm going to use this example to explain the minor. Okay, so an example is the cofactor of a11. The cofactor a11 means that I'm going to do what is I here. I have a11, so I here is 1, and then j is also 1, right? Remember, the definition is ij. Okay, so if you have cofactor 1 that means your I and j are both 1. And the minor that I'm supposed to look for is cross. What row do I have? I have row 1 and then column 1. So I'm just going to cancel row 1, column 1 of this matrix, and the sub matrix that will be left, which is 6, is what I'm going to look for. As I'm going to get and then find a determinant of that to be my minor. Okay, so what I mean is, in the first problem, or in the first part, I have the matrix to be 2, 4, -1, 6. Then I have to cancel for minor. So this is the definition of a minor. Cancel the row 1 because I have I equals 1, j equals 1, and then column 1. And the matrix that is left here is the matrix with the only element 6. And we've said this in our first or some of our lessons that the matrix or the determinant of a matrix with only one value or one element is just the element itself. So I'm going to look for the determinant of this matrix, which is 6. Okay, so the element I have there is the determinant. So then the cofactor is -1 to the I plus j, that is I is 1 plus j, which is also 1, then times the minor, which is 6, the determinant of that 1 by 1 matrix, and this is 6. In the same fashion, this is going to be -1 to the power 3, that is 1 plus 2, that is 3, and then the minor 1, 2 is just writing your matrix again and then cancelling the first row and then the second column, right? And then the element that will be left, or the matrix that will be left, you write it out and find the determinant of that. And the determinant of just a matrix with one element is that element. So this is equal to -1, which is 1 to the -1 to the 3 is -1 times -1. Okay, times -1, that will give me +1. And then in the same fashion, I'm going to get -1 here times the minor of 2, 1, and the minor of 2, 1 is cancelling 2, row 2, and then column 1. So I'll be left with 4. Okay, in that fashion, I'm going to get -4 here. In the same fashion, -1 to the power 4 times cancelling 2, 2, the row 2, column 2, and then I'll be left with the value 2. And you said the determinant of that is 2. So I'm going to get that times 2, that is 2. Okay, so these are the cofactors of this matrix. Now I'm going to go to a very big matrix, that is a 3 by 3 matrix, and try to find the cofactors here. So the cofactor here, 1, 1, is -1 to the power 2, right? Because 1, 1, I is 1, j is 1. When I sum them, I have 2 times the determinant of this matrix. I'm going to cancel row 1, row 1, column 1, and the matrix that will be left is 3, 2, 2, 1, right? I'm going to find the determinant of 3, 2, 2, 1, and then multiply it to the -1 to the 2. -1 to the power 2 is 1. So I find the determinant of this matrix here, and then we said that the determinant of a 2 by 2 matrix is the product of the diagonals minus the other side. Okay, so 3, 1, 3 minus 4, which is going to give you -1. I'm going to have that. So that's the cofactor 1 1. Cofactor 1 2 is actually going to be negative 1 to the third times the determinant of so 1 2 means I'm cancelling row 1 and then column 2. I'll be left with 4 2 3 1 as my matrix. Okay, so I'm going to find 4 2 3 1. I hope you get the trend here. So this is going to be negative 1 to the power 3 is negative 1. The determinant here is 4 times 1, which is 4 minus 6. 3 times 2 is 6, right? 4 times 1 is 1. 4 minus 6, that's negative 2 times negative 1. That's going to give me 2. So cofactor 1 2 is 2. You can do this. This is negative 1 to the 4th power times the determinant 1 3. That means I'm going to cancel row 1 and then column 3. So I'll be left with 4 3 3 2 as a matrix to find 4 3 3 2. Find the determinant of this. Negative 1 to the 4th is negative 1 to the 4th is positive 1, right? And the determinant here is 4 2 8 minus 9, which is going to give me negative 1 here. Cofactor 2 1 is actually also going to be negative 1 to the sum of these I and j. So I'm going to have 3. The determinant of delays row 2, okay, and then column 1. So you'll be left with 2 1 3 2 to deal with. Okay, 2 is it 2 1? Let me just first think about it again. So it's like row 2, cancel it, column 1, right? So it's 2 3 2 1. Sorry, 2 3, yeah, row 2 column 1. So 2 3 2 1, and the determinant negative 1 to the third power is negative 1, and then the determinant here is 2 minus 6, which is negative 4 times negative 1, that is 4, right? 2 2 is delays row 2 column 2, and then you'll be left with 1 3 3 1. Okay, determinant negative 1 to the 4th power, determinant of 1 3 3 1, right? Because you are deleting row 2 and then column 2, and then this guy is going to be negative 1 to the power 4 is 1, and then when you multiply 1 times 1, which is 1 minus 9, and that's going to give me negative 8. Now go to 2 3, it's negative 1 to the power 5, determinant 2 3, so 2, and then column 3 1 2 3 2. Okay, so I'm going to have the determinant of the matrix 1 2 3 2, and this negative 1 to the power 5 is negative 1, and then 1 times 2 is 2 minus 6, so that is negative 4 times negative 1, which is 4. Then I have 3 1, so row 3, sorry, cancel that, column 1. Okay, so you cancel that, and then the matrix that will be left with 2 3 3 2. Okay, but you have negative 1 to the power 4, and then determinant of 2 3 3 2, and this is 2 times 2, which is 4, minus 9, which is negative 5, right? Because negative 1 to the 4th power is 1. So if you go ahead and do the same thing for the cofactor 3 2, you cancel row 3 and then column 2, and you'll be left with 1 3 4 2, right? 1 3 4 2. So negative 1 to the 5, 1 3 4 2. Okay, and that is negative 1 to the 5 power is negative 1, and 2 minus 12 is negative 10, so times negative 1 is 10. And then I go to the last one, 3 3, I cancel 3, and then column 3, so it's like negative 1 to the power 6, determinant of 1 2 4 3, and that is going to be 3 minus 8, and that is negative 5, right? So these are the cofactors of this matrix, and I hope you understood this. Just remember that you have to understand what a minor is, and then just using -1 to the I plus j together with a minor, that becomes your cofactor. Okay, so that is the basis for determinant, and in the next lesson I'm going to talk about how to use the basic or the formal definition of determinant using cofactors. Okay, so see you in our next lesson.